Hello everybody, welcome to session 6. We move on now to exploring multiplication by 0, as well as dividing with 0. So today we'll follow the same procedure as we have in the past. We'll look at a little bit of literature, probably a book that many of you are familiar with and some people's favorite, and some people say, was never really my thing. So we'll take a look at that here in just a minute, and also look at a few activities for multiplying by 0. I think this session will be a little bit shorter, and you can probably imagine why. So let's go ahead and jump right on into our time here together today. We're going to slide over to our document camera just to remind us that we are now in our 5th session focusing on the facts, our 6th session overall for multiplication. And we are now looking at our multiplying by 0 facts, right? So this is our final in the first 5, really looking at what we're going to term, or the text is going to term, our foundational facts. So again, just like our times 1 facts, we know that a lot of kids are very familiar with their ones, they're familiar with their zeros, but we begin with 2s, 10s, and 5s because we want our kids to recognize that in multiplication we're talking about groups. And it's hard to talk about groups of 1, and it's probably even harder to talk about 0 groups or groups of 0, if such a thing even exists. So we may begin with the idea that zeros are the easiest. Come on, let's get them out of the way. We can show kids that they're being successful, and there's certainly some merit in the self-efficacy piece of just feeling successful. But it's probably better to hold off until we've got this grasp on 3 of the basic facts, the 2s, the 10s, and the 5s, and then we're able to talk about zeros a little bit more conceptually. So like I say, it's hard to even picture a group of 0, although there are some scenarios where we have nothing. We have a group, but there's nothing in that group from a certain category. So we'll look at a couple little examples of that today, with the understanding that 0 groups for kids is difficult to visualize and to think about. So as we look at our big picture chart, and we're actually going to make one of these at the end today, when we start to look at the big picture chart, we start to see it's starting to fill in, right? Our known facts, once we add in those zeros, if the kids have really checked off their 2s, their 10s, their 5s, their 1s, and their 0s, we're down to 36 unique facts at this point. So just those white areas on the chart now, we're down to 36 facts. And so building this really firm foundation is keenly important if we're going to make sure that kids have what they need moving forward. 2 big ideas when we think about 0. The first being that we want everyone to remember and understand that if either factor is 0, then the product is going to be 0. And we call that the 0 property of multiplication. And we're going to look at that as compared to adding 0 in a little bit. And obviously the commutative property is important in all of these, and we're going to see that again and again. And here, whether kids are really picturing 0 groups or groups of nothing, either way you end up with a solution of nothing. The concept is different, but the main idea there, the big idea, remains that you're going to have 0 as your product. We've tried to include some big ideas with each one of these chunks, and so we pulled these from the text, right? So what does it mean to multiply by 0? What is a set of nothing? Can you really have a group of nothing? Is that even possible? What does it mean to have 0 sets? When multiplying by 0, why would the product always be 0? What patterns are we going to notice? We're always going to come back to that patterning question. Does the order of the factors affect the product? And do we notice a connection between multiplication equations and division equations? Of course, you already know that there's a problem with dividing in zeros, so we'll hit that at the end today too. So we want to give kids, again, many chances to explore the facts. So even if it's groups of 0, we want to try to make this as hands-on as possible. We want to give kids a chance to explore. So we might try something like creating baskets of school supplies. Apologize for the off there, that should be of school supplies. We create groups, something like this. Something that has a marker, 2 pencils, 5 crayons, 10 paper clips. Of course, the reason we chose those numbers is those are the facts we've explored so far. we ask those quick questions like, so if I had 6 baskets, how many pencils would I have? Well, that's going to get me 6 times 2, right? If I have 3 baskets, how many crayons am I going to have? Well, that's going to get me 3 times 5. If I have 9 baskets, how many paper clips? Well, that's going to get me 9 times 10. If I have 7 baskets, how many markers is that going to be? Well, that's 7 times 1. So we're building, again, going back and connecting to multiplication sentences. And we might ask something like, how many glue sticks in 4 baskets? Oh, wait, there are no glue sticks. So can I have a group of 0 here? Or can I have 0 groups? Well, we have groups, right? We have the groups, but there's no glue sticks in there. So we might say that that's 4 times 0, right? In case if somebody added glue sticks to every basket, then it wouldn't be 4 times 0 anymore. So we can say that there are 4 times 0 baskets of glue sticks. So representing that using multiplication, doing this repeatedly with different objects. So kids could certainly do this with candy in a basket. They could do it with any set of objects, right, where one of those things is not included. So now we're going to build up and say, all right, well, let's try 2 baskets and let's ask the same question. And how would we write the multiplication equation? So 2 baskets with how many glue sticks would that be? Well, that'd be 2 times 0. How about 3? And we want kids to build that all the way up from 1 basket with no glue sticks to 10 baskets with no glue sticks and share out. Can they create the chart that shows 1 times 0 is 0 and 2 times 0 is 0? And ideally, we probably want them to be drawing that as well, right? So we've got maybe some small pictures of the baskets, and there's no glue sticks in any of them. So it just continues to be 1 times 0, and 2 times 0, 3 times 0. So that kids are starting to not just know that 3 times 0 is 0, but to understand what that means when I say 3 times 0. So our story for this for our multiplying by 0 is where the wild things are. I said at the beginning, this is one of those stories that when you ask different people, some people will say, oh, I love that story, it's one of my favorites, and other people say, Maurice Sendak's just a little different. And so some people really like this, and some people it's not their favorite. But I think when you see the activities that go along with it, I think you'll like this in terms of just student engagement, and it doesn't take a whole lot of work. It does bring in some interesting art connections as well. So we're going to start by asking kids to do a picture walk. Let's look through this. How many of you have read the story before? What do you already know about the story? And we're going to really key in on, for the math part of this, the physical features of the monsters. The horns, the claws, the teeth, the eyes, all those little pieces, because we're going to use that in the math piece here. And we want students to observe the features on these creatures in the story. So during the reading, we're going to be identifying some of the physical features that we see. We're going to be counting claws and eyes and ears. I'm not going to do that as we read it here together today, but that would be what we would want to do when we were working with the kids. And we want to make sure, again, like we always remind us, the first time through a literature piece, allow it to be the literature, and then let's look at it for the mathematics. So let me jump back over here to our document camera, and let me zoom us out a little bit here so that we can see the book. And so this is where the Wild Things Are by Maurice Sendak. And again, if you know the story and you're familiar with it, you can certainly jump ahead a little bit in the video recording here. And so the story goes a little something like this. The night that Max wore his wolf suit and made mischief of one kind or another. His mother called him Wild Thing, and Max said, I'll eat you up. And so Max was sent to bed without eating anything. So that very night, in Max's room, a forest grew. And grew. And grew until his ceiling hung with vines and the walls became the world all around. And an ocean tumbled by with a private boat for Max, and he sailed off through day and night. And in and out of weeks and almost over a year to where the wild things are. And when he came to the place where the wild things are, they roared their terrible roars and gnashed their terrible teeth, and rolled their terrible eyes and showed their terrible claws. Till Max said, "Be still!" and he tamed them with the magic trick. The magic trick of staring into all their yellow eyes without blinking once, and they were frightened and called him the most wild thing of all, and made him the king of all wild things. "And now," cried Max, "let the wild rumpus start!" "Now stop!" Max said, and he sent the wild things off to bed without their supper. And Max, the king of all the wild things, was lonely, and he wanted to be where someone loved him the best of all. Then all around, from far away across the world, he smelled good things to eat. So he gave up being king of where the wild things are. But the wild things cried, "Oh, please don't go. We'll eat you up. We love you so." And Max said, "No." The wild things roared their terrible roars and gnashed their terrible teeth and rolled their terrible eyes and showed their terrible claws. But Max stepped into his private boat and waved goodbye and sailed back over a year and in and out of weeks and through a day and into the night of his very own room, where he found his supper waiting for him. And it was still hot. So on the pages where we looked at, where we saw just the pictures of the different wild things, might be a good place to pull out how many claws, how many teeth, how many eyes, just to start bringing in some of those number pieces. So what are we going to do with this piece, and how is it going to connect back to multiplying by 0? So after reading, as a class, we're going to go through all those different features of the wild things. I would certainly chart some of them out. And we're going to create our own class monster. So let's go ahead and create a class monster. Let's think about how many eyes are we going to get, how many teeth, how many legs, wings, claws. Let's brainstorm all the different things that different kinds of monsters have. And once we have all of that built, now we get to swing in the math, right? And so now we say, okay, well, we built our class monster, and let's say he has 13 teeth, or let's say he has 7 teeth. So he has 7 teeth. Well, what if we created 2 of our monster? What about 5? What about 10? And you can see quickly we're bringing back in the multiplication facts, right? So we're saying if he has 7 teeth, if I had 2 monsters, well, now there would be 14. If I had 5 monsters, there would be 35. If I had 10 monsters, there would be 70 teeth. And so we're bringing those in. We're writing the equation so you can see the chart building out. So we've got this cool picture of this monster that we've created. We've got the list of what is 1. If we have 1 monster, how many teeth, how many claws? If we have 2, if we have 5, if we have 10, if we have... And so we're writing these out as multiplication sentences. Lots of good, rich practice there. And then we move forward and say... Let me go back one real quick. What if we thought about a body part that our monster does not have? So let's say that our monster did not have horns, for example. So we chose no, we're not going to use horns, or there's some other body part that our monster doesn't have. Well, let's put that on the chart, right? So if I have 1 monster and it has no horns, well, then I would have 1 times 0 is 0, right? If I have 2 monsters with no horns, 5 monsters with no horns, 10 monsters with no horns. So I have the monster, it's just that in that group there are none of them, right? And so that gets me my multiplication. Good place to take a break with a group, right? But then we want to keep building this somewhat rich thought of groups of 0 and 0 groups, and ask probably pairs of kids to create pairs or maybe triads or 3 groups of 3 to build their own monster. Right? So now we've got a class example, but we're going to ask them to build their own monster, and they're going to pull out what are the different features of my monster, what's the total number, and if I had multiples of these monsters, what would that look like? So now again, we've done kind of a group review of the multiplication. Now we're pulling it into, let's do some individual or some small group, and kind of creates a neat little book again to put together with. Let me back up one step. This is a place where if the kids do a nice job with the pictures and the descriptions, can create a nice book to take to a younger grade, especially if you're in upper grades. And they may only appreciate it for the pictures in it, but our older kids are looking at it for the multiplication within it. As we work through these, we know that we can't just do one example. We can't just do one tie to a literature piece and expect kids to have now grasped onto this conceptually. So we've got one other strategy is to just build a number of problem scenarios, and kids can definitely build these. So a variety of problems, looking at things like, okay, there's 4 plates on the table, there's no hamburgers on any of the plates. How many hamburgers would there be on those 4 plates? Well, how would we write that as a multiplication sentence? 7 plates in a coin toss game at the carnival, and there's no coins on any of the plates. Well, how many coins are on the plates? Well, none, right? Well, so how would I show this as a multiplication equation? So how can I find scenarios where there is an object, there is a group, but there's nothing in that group? Again, a good place for illustrations and drawing. This is kind of the pause moment, right, of, okay, misunderstandings. Kids, just like with our ones facts, kids are going to make mistakes, right? They may even have some pretty deep-seated misunderstandings that, well, when I add 0, the number remains the same. So when I multiply by 0, oh wait, it's a different concept. I've got to think of this as 3 and no more gives me 3, but 3 groups of nothing is nothing. So understanding it conceptually takes out of the equation, well, can I remember what that fact is? If I'm thinking about what do those digits, what do they represent, it's a lot easier to hold on to than simply just trying to remember 3 times 0 is 0, anything times 0 is 0. Ultimately, that's what starts to get embedded in our brain, but it's because we have that concept built in there. All right, so another way to kind of support all of our different types of learners, right? Multiplying by 0 with color tiles. So you remember our baggy activity for multiplying with 1, where we had 1 green, 2 red, 5 yellows in a bag, and we asked questions like, well, how many yellows would there be if we had 4 bags? How many reds if we had 7 bags? How many blues in 5 bags? Oh, here we are again, right? There are no blues, right? So let me go over here and remember that we do have tools like our virtual manipulatives. So let me slide me out of the way here for a second. We have our virtual manipulatives on Glencoe, on National Library virtual manipulatives. So this could be our baggie, right? This could be our little bag of stuff, right? So we draw our little bag here, and we've got our 5 yellows, our 2 reds, our 1 green, right? And we can go in here then and say, all right, well, what do we have if we have blue? What does blue even look like? Well, I don't have any blues in here. So if I have 7 bags with no blue, how many blues do I have? And of course, then that would be, well, none. Well, if I have none, so how can I write that? Well, that would be 7 groups with none in them. Means that I have none. Well, what if I have 4 groups? What if I have 3 groups? What if I have, so again, we're going back to our chart, right? And building this idea again and again and again, and kids can certainly build on that idea in the same way, not just with color tiles, not just Unifix cubes, but in a lot of different places. So we want to give kids as many experiences as we can. So one other way, or as we move then, so if we've built the concept, we've taken our time, we've built the concept deeply, one of the games in the text is Z-memory or Zemery. played just like the classic memory game, so you're flipping them over, but instead of looking for things that look identical, we're looking for things that are the commutative property of one another. So you see on this set, you've got 0 facts, 2 facts, 5 facts, a few 10 facts. The nice thing again with these is they're all in word form, so you can change those very quickly to make your own set of memory cards. You could certainly have kids have to be able to answer the fact when they turn them over. So I can't just turn over 7 times 2 and find 2 times 7, but I have to be able to tell you that's 14. So building in those pieces probably makes the math a little richer. But again, we're looking for as many ways that we can give kids experiences with the multiplication facts as possible in order to make that automaticity happen. Fact sorting. So if we give kids assorted sets of the fact cards, our times 0s, 1s, 2s, 5s, and 10s, and they're going to work with a partner to sort them based on some rule that either we give them or they decide as a team. So let's find all the ones that have products that are 0 or not 0 or less than 20, greater than 20, that are even, that are all just whatever the attribute we want to pick is. And again, we're having kids sort them, and in order to decide if the products fit, they're going to have to solve them, right? And so maybe we want to build a little bit of competition into it. You could certainly have kids sit in pairs, and they can only keep the fact or put it in their pile if they can answer the fact. So just put little copies of all the digital downloads, and again, we'll put all these on the Edmodo group so you can grab what you want, and you'll have access to them once you select this text as well. For building automaticity, another piece is to build their own multiplication chart. So we saw the chart at the beginning that was filled in for us in the text, but creating my own personal multiplication chart, like which facts do I have mastery over, which facts do I just own and I know well. So remembering the commutative property, at this point our kids know, or in theory, they know their 1s, right? So we can hit all these, right? They know I should have started in the order we had, right? They know their 2s, so they've got all these. They did their 10s next, so the 2s, then their 10s, then they did their 5s. Oops, sorry about that. Then they did their 5s. Then we did our 1s. And now, at this point in the progression, we would be doing our 0s, right? So we start to see where the unknown facts would be, kind of in those couple groups there, right? And here and over here. So having kids fill this in, which ones do you know, which ones do you own, which ones are yours? You might want to have kids fill in one color the facts that we've done as a group, and then fill in the ones that they feel like they've got. Again, I don't think this is important too early in the process, but maybe as we approach here the end of the foundational facts is a good place to say, I got my 10s and my 5s and my 1s and my 0s, but my 2s I'm just having trouble with. So I'm going to kind of highlight those, or I'm not going to put them on my chart. That's important for, I think, kids to kind of think metacognitively, if they, as much as possible, about where they are and what they know. So as we wrap up here, let's think about our connection to division. We know that division with 0s creates unique situations, and that creates interesting conversations. A lot of times up till now, we've really taught kids to think about multiplication when they see division. So if I saw 30 divided by 10, I'd think, well, what times 10 gives me 30, right? So 3 times 10 gives me 30. When I saw 12 divided by 2, I might think, what times 2 gives me 12? It's certainly, I think in most cases, that's how I think about my division facts when you're doing long division or anything else. I flip it around to the multiplication and say, what times this will give me that? And that totally works until we get to 0, right? And it kind of works with 0, right? If we have 0 divided by 2, I can say, well, what times 2 gives me 0? Totally works, right? So 0 times 2 equals 0. So as long as 0 is the dividend, 0 works here, right? And there's a couple more examples. However, when 0 becomes the divisor, you and I might understand, well, then it doesn't work, right? Because when 0 is the divisor, now we're talking about division by 0, and that's undefined, and you can't do that. But we want to make sure that we're not just telling kids it's undefined. I don't think it's important that a 4th grader is getting into the rationale behind undefined facts. But it is probably important that they realize, well, why wouldn't that work? Well, let's just follow the rule we were following. What times 0 would give me 2? Well, I know anything times 0 is going to give me 0, so what times 0 would give me 2? There's nothing there, right? So that can be a really rich conversation with kids. So we introduce this idea with fact families, right? We say, okay, here's the 4 things in the fact family. Which one doesn't seem to work? Well, 3 times 0 is 0. That passes the test, right? 0 times 3 is 0. Okay, that's just the commutative property of that one. That one works. 3 divided by 0 equals 0. Not sure about that one. And 0 divided by 3 equals 0. Well, if I think about 0 divided by 3, and think of that using my rule, right, I'd say 0 times 3 equals 0. And I don't really want to think of it in terms of the rule. I want to think of it in terms of, all right, so if I have no groups of 3, that gives me 0. I like that. In fact, it looks a lot like that one. But if I look at this other one, I'm saying 0, we'll draw a little arrow over here. If I look at this one, what I'm saying is 0 times 0 equals 3. No groups. If I take 3 and I break it into no groups, I get nothing. No groups of nothing gives me 3. Well, that doesn't work anymore, right? Making sure that kids can start to think about what doesn't work here and why doesn't it work, it's tricky, right? It's kind of even hard as adults to get our heads around that a lot of times. When we're looking at our fact practice sheets, 0 is only ever used as a dividend. We don't throw any in there where 0 is the divisor and therefore it's not going to work, and you better recognize that. We want kids to conceptually understand it. We're not trying to trick them here, but we do want to make sure that kids realize that, oh, there is no such thing as 3 divided by 0 in terms of being able to define it. As we reach the end here, I think it's important just to bring out that these are the foundational facts, right? Times 2, times 5, times 10, times 0, times 1. In whatever order we can probably argue a lot about if we wanted to, but these are the foundational facts. Without these 5 facts, the rest of them are tremendously difficult. But in fact, without them, probably the rest of them become just pure memorization that doesn't really have any root in anything and will probably quickly disappear for most kids. So if you're working with young kids, it's incredibly important to allow the process to happen, to build the strong conceptual foundation. When talking with, say, upper elementary, 5th grade, 6th grade, 7th grade, 8th grade teachers, this can be a real struggle, right? Because A, you're dealing with kids who probably have struggled with facts for a long time. I would argue, perhaps, that if the approach that's been used with them up to this point is memorization, and it hasn't worked, continuing to try to memorize probably still won't work. So it may be painfully slow, but it may be the only thing that works for our kids, even if they've been struggling for a long time. So think about that a little bit. I'm always interested in people's thoughts when it comes to this. So our follow-up question to this one, in fact, the assignment for this section is going to be just about that. What do you think is the most effective when it comes to working with kids who struggle with these foundational facts? Is it to press on memorization, or is it to build a concept, or is it some blend of the two? So that is our to-do, and I'll post that as our assignment. I hope these first 5 have gone well for you. I know it's a lot for anyone. And please do make sure as we head on into the next set of facts here that you may want to set aside time for this PD in the same way you would if you were doing it face-to-face, and just say, hey, on Mondays from 3:30 to 5, that's what I'm going to do this professional development. I know the reality for a lot of people is it's late at night. I hope that this is worthwhile for you. And so let me know how we can make this better, and we will be glad to do that. I apologize I didn't take out the up next part here, but obviously up next is not times 0. Up next will be times 3, and so we will jump into that here shortly. Thanks again for your time, and I look forward to working with you.